at AP Review. This is 2011 Form B, AB Free Response 6. So let G be the piecewise linear function defined as followed from negative 2 pi to 4 pi, and graphed here, but better on the real AP. And let f of x be defined as f of x equals g of x minus the cosine of x over 2. Part A, find the integral from negative 2 pi to 4 pi of f of x dx. Show the computations that lead to your answers. So if I want to integrate f of x, so in part A, right, I want to integrate f of x from negative 2 pi to 4 pi with respect to x. So the trick is that f is actually two things, right? It's going to end up being the integral of g of x dx from negative 2 pi to 4 pi minus the integral of cosine of x over 2 from negative 2 pi to 4 pi with respect to x, right? So this piece is just the area of the graph, right? So this graph has a base of 6 pi, right? Because this is 1, 2, 3, 4, 5, 6, and each one of these hash marks is a pi, and it has a height of 2 pi. So this is going to be a triangle that has 1/2 the base times the height, so I'm just going to get that it's 6 pi squared, right? This guy is technically u substitution, right? My u is the x over 2, but the trick is that if I understand that's what's happening, then if I were to derive cosine of x over 2, every time I derive, I would have to multiply by 1/2. So if I'm going to integrate cosine of x over 2, every time I integrate, anytime I do the antiderivative, I'm going to have to divide, instead of timesing by 1/2, I divide by 1/2, which is the same as timesing by 2. So what's going to happen is I'm going to get that this is a negative 2 sine of x over 2, right, evaluated from negative 2 pi to 4 pi, right? So what's going to happen is I'm going to get that this is a 6 pi squared, right? Because the 1/2 would cancel with the 2. My marker has just decided to quit on me, which is quite unfortunate. So I'm going to get this as 6 pi squared, right? And then when I go ahead and plug in these values, I'm going to get minus 2 sine of 2 pi, which is totally a 0, right? Minus a 2 sine of negative pi, which is also totally a 0, because sine of all the pi's are zeros. So I'm going to end up getting that my final answer is just the 6 pi squared, right? So it turns out that that whole second bit didn't matter in this instance, and it was just a 6 pi squared. Part B. Find all x values in the open interval from negative 2 pi to 4 pi for which f of x has for which f has a critical point. Okay, so we need to translate what we're asked. Sorry, this is the graph of G again. I didn't mean to erase that. Okay, so in part B, we're asked for f of x critical points, right? That's what we're asked to find. And then we're not asked to do anything with them. We're just asked when do they have critical points. So the trick is that there's 3 basic kinds of critical points, right? So one is when f prime is 0. The next is when f prime does not exist. And then the third one would be included endpoints, but in this problem there aren't included endpoints because although the endpoints were included in the original, the endpoints are not included in part B. They specifically did the open interval. So I need to look for these 2 spots, right? So in order to do that, right, so this is the definition of what it would mean to be a critical number or a critical point for f. I then need to translate that to what I can see in this particular problem. Well, I should probably derive f, right? So f prime of x is going to be, and I'll just inch this over a little bit for you, g prime of x minus, now when I derive this negative cosine of x over 2, right, the derivative of negative cosine is positive sine, and then I'm going to have to times by 1/2, so I'm going to get plus a 1/2 sine of that x over 2, right? Timesing by 1/2 is that chain rule, right? So, so that's what I'm going to get, right? So I then need to look at the fact that this is fundamentally a piecewise function. A couple things are going on here, okay? The first thing that's going on is that g prime of x does not exist when x is 0, right? So this thing doesn't exist at 0, which means right away, if part of f prime doesn't exist at 0, then the whole thing doesn't exist at 0. So f prime does not exist at x is 0, right? That's going to be a critical point, right? The other possibility for critical points are that this f prime is 0, but in order to consider that, I'm going to have to recognize that f prime is actually fundamentally a piecewise function because g prime, right, g prime is the slope of the given graph, right? And that slope of the given graph, it's 2 linear pieces. This is a rise of 1 overrun, right? You went up a single pi over a pi. So this is a slope of 1, and this is a slope of down 2, right 4. So this is a slope of negative 1/2. So essentially, what's happening is that f prime is actually a piecewise function. F prime of x is a 1 plus 1/2 sine of x over 2 for x values from negative 2 pi to 0, but not including either, because specifically we weren't supposed to include the endpoint of negative 2 pi, and at 0 we already established f prime doesn't exist, and f prime is a negative 1/2 plus 1/2 sine of x over 2 for the values starting at 0 and going to 4 pi. So essentially, I need to set each piece of these to 0 and see if either of them gives me a critical number. So when I go to do that, so let's start with, I'm just going to call this guy A and this guy B just to make it a little bit easier. So when I set A equal to 0, so 0 equals 1 plus 1/2 sine of x over 2, we get negative 1 equals 1/2 sine of x over 2. So we get negative 2 equals sine of this x over 2. Well, a sine can't be a negative 2, because if you picture a sine, like sine of anything, maxes out at 1 and mins out, for lack of a better way to say it, at negative 1, so this is going to have no solution. So this option doesn't have any spots where f prime is 0, but B might. So the second one is negative 1/2 plus 1/2 sine of x over 2 equals 0, right? If I move the negative 1/2 over, I get 1/2 sine of x over 2 equals 1/2. I divide by 1, and I get that sine of x over 2 is a 1, which totally can happen, and does happen at pi over 2 on the unit circle. But because of this x over 2, right, essentially whatever answer I get when so this would mean go half the length around the interval that you're looking at, right? So the interval we're looking at is 0 to 4 pi, so I would go one full length around, but the only answer that would end up happening anyway is at pi over 2. So I would get that x over 2 equals pi over 2, and sure enough, that gives me x is pi. That is the other critical value, and you'll notice it does fall in that window from 0 to 4 pi. So the two critical numbers that I get in part B, right, are 0, where f prime does not exist, and pi, where f prime is equal to 0. So those are the two critical points. Part C. Let h of x equal the integral from 0 to 3x of g of t dt. Find h prime of pi over 3. Okay, so for C, h of x equals the integral from 0 to 3x of g of t dt. They want h prime of negative pi over 3. So I need to find h prime first. So when you do the derivative of an integral, the second fundamental theorem of calculus says that basically what happens is differentiating and integrating cancel out as an action. Oh, sorry, it's a dt. My bad. These cancel. I plug this guy in for t, and then I do dt, minus I plug this guy in for t times dt. So what's going to happen is I'm going to get g of 3x times the derivative of the 3x, which is a 3, minus g of 0 times the derivative of 0, which is a 0. So I'm going to get that h prime of x is a 3 times g of 3x. So h prime of negative pi over 3 is a 3 times g of negative pi, right? Because negative pi over 3 times 3 would just be a negative pi. So I go to where my g of negative pi is, and I realize that at negative pi, g has a value of pi, so I get 3 pi, and that's my final answer. The end.